Hello everyone. So today we will be solving another dynamic programming problem. This is my second video for the DP series. So what this problem says, in this problem we have been given that we are given two strings and we need to return the lowest ASCII sum of deleted characters to make two strings equal. So I hope if you have come to this video you would have already read this question. Now let us see what this question actually says, or let's summarize this question. So if you can see C and eat, so after C and eat we can see that EA and EA are common, S and T are different. So we need to delete S and T from S1 and S2 and we need to return their ASCII sum of values. So the ASCII value of S is 115 and the ASCII value of T is 116. So upon adding the both we get 231 and we return 231 as our answer. So how do you approach this problem? Because the first intuition is very important, like how do you actually intuit this problem? So we can say that at each index, like I will be taking one index at string s1 and I will be taking the other index at uh, string s2. Let me explain it using printf. So if I am taking a string, this is s1 and this is s2, the indexes of s1 will be I and the indexes of s2 will be j. So there will be two cases arising. What, if s1 of I is equals to s2 of j? So in this case what you actually need to do, you do not need to delete anything because the two characters are equal, and deleting anything will make actually more to your sum. So what you need to do is you just need to call your further functions, and by using I plus 1 and j plus 1, this, right? And what is the second case? The second case is that if my s1 of I is not equals to s2 of I. What does that mean? It means that the two characters of string s1 and s2 at indexes I and j respectively actually are not matching. So what we need to do is we have two options here. Either we can delete the character present at ith index in the string s1, or I can delete the character present at the jth string in the string s2. So among these two we will have to take the minimum option, minimum, because the question is asking for the minimum sum of deleted ASCII values. So this will lead to two different cases. The case one will be we are deleting the string s1. So if we are deleting the string s1, I will be adding s1 ASCII value to the answer and then calling the further recursion calls for I plus 1 and then j. In the similar fashion I will be taking a case 2, and in case 2 I will be deleting the jth character present in string s2, and after that I will be calling the function for this, and among these two I will be returning returning minimum of c1 and c2. So this is the whole like recursion logic, but this is recursive code, but we can actually memorize it. Why memorize it? Because it will give time limit exceeded. Why time limit exceeded? Because it is very clear that at each step you have two options. Either, I mean, if the string matches you have just one option, or if the string does not match you have two options, and among those two options you are taking the minimum. So while going deep into the recursion tree you will be having a lot of it will take a lot of time and the time limit will exceed. So what we can do is, since it is a recursion code, we can optimize it by using dynamic programming. uh, now we need to decide what would be the size of the DP array. So the size of the DP array is actually the number of changing variables at each recursion call. So while making each recursion call, what are the changing variables in the code? While making the recursion calls, the changing variables are just two, that is I and j. At each recursion call the I and j indexes are changing. So the DP state of this question will be dp of n comma n. What I mean to say is the size of DP array will be dp of n comma n, where n is the size of s1 and m is the size of s2. I hope this question is clear to you. Now while I mean recursion, if you have written the recursive code, it's very easy to write DP code, right? Now let me make changes. What will be the changes in the DP code? So there is a line that if DP of I comma j is not equals to -1. So what we will include this line. What this line actually does, this line actually tells us that if there is some value stored x that is not equals to -1 in the DP array, we are gonna simply return it. And if we simply return it, we are not going to make further recursion calls from this element x. So that will actually save a lot of time, and the space complexity will reduce from exponential to order of n square. Why order of n square? Because the DP state is O of n, and O of n square. Now talking about the time complexity of this recursive code, that will be exponential. And talking about the time complex, this is the recursive time complexity. This is the recursive time complexity. And talking about the DP time complexity, it will be O of n square, and the space complexity will be O of n square. Why O of n square? Because we are using a DP of size n cross m, and it is a 2D array, so it will be space complexity will be O of n square. Now let's head on to the coding section and see how is the code. Yeah, so yeah, simply we have made a DP array of size n cross m, and we have called the solve function. And in the solve function, we have passed the string s1, string s2, and the indexes, starting indexes of the string s1 and s2. The very first important thing is that the base cases of this question, because we have not discussed base cases yet. So let's discuss the base cases also. What will be the base cases? Actually, we need to understand what is actually a base case. Base case is something where your DP will, where your DP or the recursion call will stop. I hope you would have read the binary trees or trees concept. So the last node of binary tree is called leaf. At that point, we need to return. So I mean, if there is a recursion call, we need to stop the recursion call at some point of time. So that recursion call at some is stopped at some point of time using base cases. So what will be the base cases? The first base case will be if I is equals to n and j is equals to m. What does this mean? This means that my both string s1 and s2 are over, and we have reached at the last index of the array. I mean, we have surpassed the last index of both string s1 and s2, and we are gonna return 0 from here, The second base case is, think of if I is not equals to n and my j is equals to n. In case my j will be equals to n, what does it mean? It simply means that my s2 string is completely over, and now I do not need to delete anything from string s2, but my string s1 is still left. So what I actually need to do, I need to remove some characters from I need to remove actually all the characters from string s1, starting from the ith index to the n-1th index. So I am gonna remove each and every character present in string s1, starting from the ith index till the n-1th index. So this will be the second base case. What will be the third base case? In case my I is equals to n and my j is not equals to m. What in this case scenario, what we need to do is we simply need to what this case actually tells. First, try to understand that in this case I is equals to n means my first string s1 is completely finished. I do not need to delete anything from the string s1. What I am left is with just the string s2, starting with the jth character till the m-1 character. We need to delete everything from the string s2 in order to make both the strings equal. So what I need to do in this recursion case, I simply need to return sum of all the values, sum of all the ASCII values of the string s2 starting from the jth index till m-1 index, and then we need to return the sum. So these are the three base cases that we need to handle. Now again, let's go to the coding section. Yeah, so in this problem, in this function, we are taking this is the DP function. If the first base case was if I is equals to n, if my j is equals to m. What does it mean? Again, I am repeating. It means that both the strings are over. I do not need to delete anything from both the strings, and I am gonna simply return a value of 0. And the second base case is if my I is equals to m and my j is not equals to m. What does this mean? This means that my first string s1 is completely over, and my second string s2 is left with is left with characters from j to m-1, and I need to delete those characters of s2 from j to m-1. So I simply need to sum it up and then return sum. And the third base case is if my I is not equals to m and my j is equals to m. This base case is similar to the second base case. I hope you would have understood. Now Now we have used this memorization technique here. If my dp of I comma j is not equals to -1, if what does this statement means? This statement means that if something is stored in my dp table already, I'm gonna simply return it, and I'm not gonna process it further. I'm not gonna make any further recursion calls from that dp state. So this line means this. And in case my string s1 and string s2 are the ith and jth characters respectively are matching, we are gonna simply move ahead I plus 1 and j plus 1, and not gonna add anything to the dp state, because they are actually matching and we do not need to delete anything, and deleting them will lead to more value, more sum. Acha, the second case is in case my string s1 and s2 at the ith and jth characters are not matching, we are simply gonna return the minimum value of I plus 1 comma j state and I comma j plus 1 state. So I hope this problem was very clear to you, and if in case you have any doubt, please ask me in the comment section, and do subscribe the channel for more such videos, for more such dynamic programming, graph, interview preparation tips. Thank you.